Okay, today we are going to do SOHCAHTOA review, and just so you recall that acronym, SOHCAHTOA is sine is opposite over hypotenuse. So if we're looking at this picture here, sine will be opposite over hypotenuse, and make sure you're paying attention to where your angle is. So that's theta, so the opposite is over on that side, and cosine is adjacent over hypotenuse, while tangent is opposite over adjacent. And that's how you get the acronym SOHCAHTOA. And we're just going to look at that one more time using this picture. So theta's over here, which means, and I know it's a little blurry, but we're going to use these sides. So sine of theta is going to be that opposite, which is over here at A, and the hypotenuse, which is C. And we'll do the same thing for cosine, which is adjacent, and that B, that is adjacent to that angle. So cosine of theta is B over C. And you'll just divide the magnitudes of the lengths. And finally, tangent, you do opposite over adjacent. So tangent of theta is A over B. And now we're just going to do two really quick examples to show you how we're going to use SOHCAHTOA in this class. So for this first problem, we're going to look and find what the length of y is right there. And so we're using this angle down here, which is 59 degrees. And we have the hypotenuse, which is 17. And so we have y is opposite of 59, so we'll be using sine. So we get sine of 59 because we know what theta is in this example. And it's opposite over adjacent, so y over 17. And we're just going to use a little bit of algebra to figure out y. So we'll move 17 over. So multiplying both sides by 17 gives 17 sine of 59 degrees. And then you can just plug that directly into your calculator. Make sure your calculator's in degree mode. And you'll get y equals 14.572. And that's it. And in this next problem, we're going to be solving for theta, so the angle, which means we'll be using an inverse trig function, and you'll see that in just a second. But in this example, we have all three side lengths, so you can choose whether you want to use sine, cosine, or tangent. Personally, I'm going to use cosine just because, and so that's adjacent over hypotenuse, which gives, so 20 is that adjacent side, and 29 is the hypotenuse. So cosine of theta is 20 over 29. Now, to get theta by itself, we use what's called inverse cosine, and you can write it just like this, and it's a function on your calculator, just like cosine is, and you'll do it to both sides to cancel out that cosine there next to theta. And so when you take the inverse of both sides, these cancel each other out, and you get theta. And you're just going to plug that into your calculator again, making sure that it's in degree mode because we're going to solve this in degrees, and you get 46.397 degrees. And so that's the final answer. Like I said, you could have used any of the trig functions. So you could have used tangent, which would have been, you would take the inverse tangent of 21 over 20, or you could have used sine and done the inverse sine of 21 over 29. All of those options would have given you the same answer, which is that.